So here's another linear approximation problem. Excuse me. Sorry, it's going to be number 7A from the textbook, doing an approximate of a fourth root and finding that without, again, having the aid of a calculator with a fourth root. And then we'll do number 10 as well, because 10 was from the homework, and some of you guys made kind of a big mistake with what you did to find the values. So we'll talk about those. So 7A first, we need to create a function that we would use to approximate a fourth root. And our function we would use is just the fourth root function. So, which is f of x equals the fourth root of x, which more importantly is f of x equals x to the 1/4 power, which we'll want for finding the derivative. Now the next thing we'll have to do is figure out, well, what's our x naught? And since I'm doing the fourth root of x, I want to find something that has a fourth root close to it, 16. So our x naught is going to be 16 because the fourth root of 16 is 2. So that's an easy value for us to use to approximate for fourth root of 16 to the 1/4 power, or 16.04. So now that I've gotten my initial value set up, what I need to do is find for my L of x. I've got f of x naught already. I need f prime of x naught, which means I need to have the derivative of f of x. It's an easy enough derivative to find, just a simple power rule. So 1/4 x to the negative 3/4, because I'm going to subtract 1 from the 1/4. That means f prime of 16 then is 1/4 times 16 to the negative 3/4 power. We're going to take the fourth root of 16, which is 2, cubed, which is 8, but since it's a negative exponent, it'll be 1/4 times 1/8, which is 1/32. So that's going to be our slope. So my linear approximation, the line for it, f of x naught was 2, slope was 1/32, x minus x naught, which was 16. Okay. So there's the equation of our line. Now I'm going to use this equation to find an approximation for the fourth root of 16.04. So that'll be L of 16.04 equals 2 plus 1/32, 16.04 minus 16. And I mean, you can throw in your calculator and get a decimal approximation if you'd like. Just do that for the sake of time. So 2 plus 1/32 times 16.04 minus 16 which is 2.00125, or as a fraction, um, 2 1/800ths. So that's our approximation. Right. Now, the next problem I'm going to look at is problem number 10. And problem number 10 isn't terribly difficult, but what issues you ran into for those of you that got it wrong on the homework was that you used really the wrong slope. Okay. So for number 10, we're still going to use L of x equals f of x naught plus f prime of x naught times x minus x naught. Now the thing is, we have to approximate this. We're actually using approximations for all of these, but this one I'm going to have to do even more because I can't find a derivative for the graph. But what I can do is I can use a slope using 2 points here, either this ordered pair or these two ordered pairs, and then use that to allow me to evaluate an approximation for 72 degrees. Now, the issue was when you're doing 72 degrees, we have to decide which point to approximate closely to. And what you have to do is figure out what number is it closer to. Well, 72 degrees is in between 60 and 80. So I want to use the points who use 60 and 80 for their slope. I don't want to use 80 and 100 because that's further away from 72. And that's what happened in the homework. Was some of you found the slope between 80 and 100, use that value, and then use that to approximate 72. Well, the issue was that's away from 72. So my f prime of x is simply going to be the slope between 80 and 60. Now, another thing that happened too is some of you guys did 80 minus 60 over 120 minus 84. Well, that's the change in x over the change in y, really. So we have to flip that. Make sure we do 120 minus 84 over 80 minus 60. Or switch those, so make sure it's the change in f of x over the change in x. So that gives us then, what, 36 over 20, which is 18 over 10, which a lot of you guys just said 1.8, which does work out that exactly, so we can use that. So there's our change in x, okay? But more importantly, this is our f prime of x, and I should have put this here, f prime of what we'll call 80, because that's the value of the 3 that's closest to 72. So f prime of 80 is 1.8. And now what I'll do is I'll use f of 80, because that's the closest number of the 3 to 72, which is 120 as my now values to use to plug into my linear approximation formula. So the linear approximation formula is 120 plus 1.8 times x minus 80. There's the formula for it. Now what I'll just do is plug in 72 for x. And again, I can just throw that in the calculator to do all the arithmetic for me. And I get 105.6. And our units here is number of soft cans sold. So soda cans, sorry, soft drink cans. So at 72 degrees, we can expect to sell around 105 or 106 cans. Now, the next problem you do for part B, you do the same thing, but this time you would use 180, both of those points, as the values you use for your slopes. And then your f of x prime would be f of 100, because 100 is closer to 94 than 80 or 60 is. So we'd use these 2 points because they're the closest 2 points to 94 for the slope, and then we'd use f of 100, so 100 for x naught and 168 for f of x naught to approximate it.